Find the interval of convergence and radius of convergence of the series below. And the series is n equals 1 to infinity, negative 1 to the n, times x minus 5 quantity to the n. And that's all over 4 to the n and the cube root of n. You have to do the limit as n goes to infinity from a sub n plus 1 divided by a sub n. All inside of absolute value. And so we'll do limit as n goes to infinity. And we notice that we have 4 different terms, one fraction for each term. And if we do a sub n plus 1 divided by a sub n, the numerator will have all that, the negative 1 to the n plus 1, and the x minus 5 to the n plus 1. Well, the denominator will have the 4 to the n plus 1 and the cubed root of n plus 1. The other terms will be using n. We have negative 1 to the n, x minus 5 to the n, 4 to the n, and finally the cube root of n. We'll do each one of these limits separately. Anything raised to the n plus 1 we can factor out to make it so that it's that number to the n times that base. And so we'll have negative 1 to the n times negative 1. We'll have x minus 5 to the n times x minus 5. Okay, great. So the negative 1 to the n's would cancel, the x minus 5 to the n's would cancel, and the 4 to the n will cancel. The cube root of n over the cube root of n plus 1, the limit as n goes to infinity on that is 1. So we have a 1, a 4 in the denominator, an x minus 5 in the numerator, and a negative 1 in the numerator. So it's negative 1 times the quantity x minus 5 all over 4 inside of absolute value. And we need to force this to be less than 1 for convergence. And what we'll do is we'll take out the fourth and have just x minus 5 in absolute value. And then we times both sides by 4. Okay, great. So the absolute value of x minus 5 is less than 4. Once you get the absolute value of x minus a being the center, when you isolate that term, the r is what's on the other side there. So the radius of convergence is 4. And what we have here is that it's centered at 5, and the radius of convergence is 4. If the absolute value of x minus 5 is supposed to be less than 4, then you can go 4 in each direction from 5, essentially, to get the endpoints. If we take away 4, we end up at 1. When we add 4, we end up at 9. And so we still have to check the endpoints, though, to see that, to check the convergence at the endpoints x equals 1 and x equals 9, but 4 is the radius of convergence. Alright, great. So let's check the endpoint. When x is 1, we'll have the summation n equals 1 to infinity, negative 1 to the n, 1 minus 5 to the n, and a 4 to the n in the numerator, and the cube root of n. I'm sorry, 4 to the n in the denominator and the cube root of n. All of these to the n terms can be put together. 1 minus 5 is a negative 4. And so we have a negative 1 and a negative 4 all over a 4, and the whole thing is to the n. And then we also have that cube root of n. So when all said and done, this becomes just a 1. This whole thing is a 1 raised to the nth power. And 1 to the n will translate to just a 1. And so what we have then, finally, n equals 1 to infinity, 1 over n to the 1/3 power. Convergent or divergent? It's a p-series with p equals 1/3. So divergent. When x is 9, we have the summation n equals 1 to infinity, negative 1 to the n, 9 minus 5 to the n, and the 4 to the n, and the cubed root of n. This time, we'll have a negative 1. This here is a positive 4. And that's all to the nth power. And so this all will combine this time to be a negative 1 to the n. It makes a difference. What we're looking at now is a negative 1 to the n over n to the 1/3 power. Alternating. And so for the alternating series test, we take the b sub n to be just the 1 over n to the 1/3 power, and the limit is n goes to infinity on the b sub n is 0, and it's also decreasing. The larger n gets, the smaller the terms get. So these two together mean convergence by an alternating series test. And so the interval of convergence is divergent at 1, convergent at 9. That's the answer. Where we use the square bracket for convergence, parentheses for divergent. Okay.